You're watching A-League
Math. Samuel Kim Production.
Okay, last section of chapter 4. Sorry, I'm eating a vitamin C tablet, so maybe you can hear me sucking on the tablet. Sorry. In any case, first part should be pretty easy for you, I hope. I'd like you to solve the following equations. And I want to do this as a quick review before I actually show you how to solve trigonometric equations. They're actually quite similar. But before I actually do the trig questions, let's see if you can do these. Alright, A. How do we solve A? Yes, group all the x's together, group all the numbers together. So, how about subtracting 3x on both sides? So you'll now get 2x minus 3 equals -2. I guess I'll now ask you to add 3 to both sides. 2x equals to what's -2 plus 3? How about 1? Solve for x by dividing both sides by 2. X is 1/2. Easy. How about the next one? Well, this is a quadratic, and there's a special way to solve quadratics. I suggest you move all the terms to one side, and you've got it. Factor. Okay. Hope you remember how to factor this. Find two numbers and multiply to 4. Same two numbers add to the constant term 5. The correct two numbers are 4 and 1. So x plus 4, x plus 1 equals 0. Remember, you're solving, so therefore we make each of the individual brackets equal to 0. So you get x equals to -4, and x equals to -1. Ta-da! Okay, part C. Part C you can do different ways. You can factor this one. If you remember, this is a difference of squares, so you can factor it. 2x plus 1, 2x minus 1 equals 0. Then, of course, we make each of the factors equal to 0. So that's one way. Now for this one, there is another way. Because there's only an x squared term, this is a little bit different than part B, because there's only an x squared term, I could ask you just to isolate x. So move the 1 to the other side, divide both sides by 4, sorry. Then take the square root on both sides, and don't forget the plus minus, and the square root of 1/4 is 1/2. So, same answer as above. Only do this if it's just x squared by itself. Even the one in part D. A lot of people do this. Oh, squared, x cancel out, x equals to 1. Not so fast. Okay? My suggestion, once again, is like part B, move everything to one side. X squared minus x equals to 0. Then I want you to factor, but this time I want you to factor out what I call the greatest common factor amongst those two terms. What's the greatest common factor between x squared and x? Yep, you said it, x. So I'm going to ask you to factor out the greatest common factor. In this case, it's x. And this is the issue. If you don't, or if you did actually that canceling out earlier, you still get that answer of x minus 1 equals 0, therefore x equals to 1. But you lose this answer where x equals to 0. So there are actually two answers for this one. Okay? These are just some quick review of solving equations. If you can do those from above, well, you can definitely solve trig equations now, because instead of using x, we now replace it with one of these 6 trig ratios that we learned last day, and we solve it the same way. Let's give it a try. See how example number 1 looks very similar to Review example number A. All I did was replace x with sine theta. So let's try to solve this. Just like how we did A, we want to subtract 3 sine theta on both sides. You get 2 sine theta minus 3 equals to -2. What's next? We'll add 3 to both sides. 2 sine theta equals to 1. What's next? We'll divide both sides by 2. So sine theta equals to 1/2. What's next? Hey, this is just like last day. To solve for theta, we will now take inverse sine of 1/2. This is from the special angle table. And if you have that handy, look back at it. I hope you have it memorized actually, but that's okay if you don't. Do it by the test. This is actually pi over 6. Is that the final answer? Or all the answers? Well, not so fast. So I'm asking you for the domain between 0 and 2 pi. Remember this all students take calculus business. Well, your first answer is here, pi over 6, but there's another one. Yeah, over here in the second quadrant, because that's also where sine is positive. To find the angle in the second quadrant, we take pi, or 180 degrees, minus our reference angle of pi over 6. 6 pi over 6. Take away pi over 6. That's 5 pi over 6. 2 answers. Done. Okay. Going to follow up each example today with an exercise that's similar, but with a little twist. So I'm going to ask you to try at least to do part of exercise 1 by yourself. Okay? Stop the tape, try it yourself, come back when you're stuck. Remember, just treat the trig ratio just like x. Need to isolate the trig ratio. In this case, the trig ratio is one of those reciprocal identities. Let's rewrite it using the primary trig ratios. We'll flip it around, of course. That's just cosine theta equals to 1/4. And now we're in business to try to solve this. Solve for theta by taking inverse cos. This one's not one of the special angles, so bring out your calculator. Make sure you're in radian mode. Good, good, good. Second function cos, 1/4. Get this answer, hopefully, 1.32. So that is one of our solutions, but I want it in the domain from 0 to 2 pi. Well, I think we have to do ASTC again. Cosine's positive in quadrant 1. Also positive in quadrant 4. To find out the angle in quadrant 4, that's 2 pi minus the reference angle of 1.32. 2 pi 6.28. 6.28 minus 1.32. How about 4.96 radians? If you got those two answers, congratulations. Alright, let's turn to page 2. And we're going to look at exercise number 2. If you remember part B we solved x squared plus 5x plus 4 equals 0. Now instead of having x, I replaced it with tangent theta. So same idea here, we're looking for two numbers that multiply to 4 and the same two numbers that add to 5. Of course we found this earlier, 4 and 1, 4 and 1. So instead of having x plus 4 and x plus 1, we now have tangent theta plus 4. And we also have tangent theta plus 1 equals 0. Well, ultimately, we're solving each of these equal to 0, so tangent theta plus 4 equals 0, or tangent theta equals to negative 4. To solve this, of course, I'm going to ask you to find the inverse tangent of negative 4. And I don't know how to do this without the calculator, so you can use one too. Inverse tangent of negative 4, we get an answer of negative 1.325. So how about negative 1.33? Unfortunately, this answer is not in my domain. So I better add 2 pi, the coterminal angle, to get it in my correct domain. Add 2 pi. So 4.96. There we go. 4.96. That's one answer. Once again, tangent is negative in this case. So I believe that 4.96 must be in quadrant 4. We need to find the other answer, which would be in quadrant 2. What's the reference angle? Well, I think this reference angle here will be 6.28 minus 4.96. And if you do that, guess what? You get that 1.32 thing. Okay? So, if I want to find the angle in quadrant 2, remember, angles in quadrant 2 are always pi minus the reference angle. So 3.14 minus 1.32, what would that be? 4 minus 2 is 2. 1 minus 3, that's 8. 1.82. Okay? Are we done for this one? Nope, because guess what? We've got tangent theta plus 1 we still haven't solved for yet. Oh yeah. So tangent theta plus 1 also equals 0. Therefore tangent theta equals negative 1. We'll solve for theta. That's inverse tangent of negative 1. If you're not too sure about this one, whoops, wrong one. Not too sure about this one? Well, once again, just take inverse tangent of negative 1. Get the answer of negative 0.785. Hey, wait a minute. I should have known this one. What is this? As a fraction, radians. It's a special angle. Yeah. Pi over 4, right? Special angle. Pi over 4, but because this one's negative, this is negative. So once again, A, S, T, C, we have an angle of negative pi over 4 here. Of course, that's no good because I want you to write that in terms of 0 to 2 pi because of my domain. So let's add that together. I think that's 7 pi over 4. Once again, that's not the only answer. Yes, there's one more. This question has 4 different answers over here. Once again, quadrant 2 will take pi minus the reference angle of pi over 4. So the final answer would be 3 pi over 4. Pretty tricky with a quadratic, eh? Had to factor, then solve 2 linear ones. Each of the linear ones have 2 answers. Wow, 4 answers. So much work. But that's okay, because you like work. So I'm going to ask you to try exercise number 2. This one's a little bit trickier to factor. Remember, there's many different ways to factor, so I'm not really going to show you the different ways. You can do decomposition, guess and check, the choose method, whatever you wish. So I'm not going to actually show you. I would like you to review if you can. We've done this in chapter 3, by the way, so go back to your chapter 3 notes and take a look at how to factor. But let's see if you can solve this one. Once again, try it on your own, then come back and check your work. Oh, I smell special angles. Yay! Nice exact values. Inverse sine of half is, I think, just pi over 6. Once again, all students take calculus. We have an answer in quadrant 1 of pi over 6. Where else is sign positive? Yes, how about quadrant 2? So that's, of course, pi minus pi over 6. And that just must be 5 pi over 6. Okay. Going the other side here, sine theta minus 1 equals 0. Sine theta equals to 1. Theta is inverse sine of 1. If you're not too sure what that is, go to your calculator. Inverse sine of 1 is just 1.57. Well, that's just pi over 2. And if you forgot about that, remember, sine is the y value. So what angle gives you a y value of 1 in the unit circle? It's 90 degrees. And in this case, there's only one answer because, hey, it's positive. So it's in quadrant 1 or quadrant 2. These actually are the same thing. So notice here, we have only 3 answers, not 4. Okay, so you can most of the time have 4, but sometimes if one of the angles is on the actual coordinate grid, you may only have 3. Okay, turn the page if you're ready for the next part. Hey, didn't we do this one again? It's 4x squared minus 1. So once again, if you like to factor by difference of squares, by all means. If you don't, because you like to solve, you can do that as well. Up to you. I'll solve this one because it's just a square term by itself. So 4 cosine squared theta equals to 1. Cosine squared theta equals to 1/4. Once again, you're trying to square root both sides, so square root of cosine squared theta is just cosine theta, and that square root is just 1/2. Oh, by the way, if I didn't mention this to you before, cosine squared theta is the same thing as cosine theta all squared. In trig, we decided to put the 2 in between the function and theta because if we didn't, and if I left it like that, people got confused. Was it actually theta squared first and then do the cosine? Or was it asking do the cosine theta first and then square it? Okay? I think it's kind of redundant, but nonetheless, cosine squared theta is cosine theta all squared. So here we have 2 answers, by the way. Back to the question. Cosine theta equals to 1/2. Cosine theta equals to negative 1/2. Once again, this is a special angle, so cos inverse of 1/2, I believe, is, I think that's pi over 3. Once again, all students take calculus. Here's the answer in pi over 3. The other answer must be in quadrant 4. So to find the answer in quadrant 4, what do we do? Yes, it's 1 complete rotation. That's 2 pi minus pi over 3. 6 pi over 3 minus pi over 3. 5 pi over 3. Oh, don't forget there's more on the other side, so cos negative 1 of negative 1/2. Well, that's actually equal to negative pi over 3. Gotta change this to answer between 0 and 2 pi, so I'm going to add... Wait a minute. Cos negative 1, negative 1/2. Is that really negative pi over 3? Let me just check on my calculator. Cos negative 1, negative 1/2. I don't think it actually is. Yeah, 2.09. Whoa, what's that? Well, think back to what... Think back to that unit circle, if you can. Cosine is x values, right? So this is saying the x value is negative 1/2. Which angle gives an x value of negative 1/2? Oh, it's not even in this notes. It's in the other notes. Let me find them for you. Oops. Let me try to find it for you. Last day's notes. Hope my computer will not freeze because of this. Was this a mistake? Maybe. Oh, no, here we are. Let's go back up to last day's notes, page 1. We were looking for where cosine, or the x value, is negative 1/2. Oh. Do you see? Do you see? Do you see? Cosine of 120. There's one. Where else do you see it? Oh yeah, cosine of 240. So those are your answers, right? What are they? 2 pi over 3 and 4 pi over 3. How do we get those answers? Well, once again, cos negative 1 of negative 1/2 on your calculator was this. That's equivalent to 2 pi over 3. Yes? Oops. How about 2 pi over 3? Yep, so it's the same. So 2 pi over 3. That's one answer. This is the one in quadrant 2. See how important that ASTC thing is? Well, the reference angle in this case would be this tiny one. It would be pi over 3 because they have to add up to pi. And so your other answer in quadrant 3 would be theta equals to pi plus pi over 3 or 4 pi over 3, which isn't confirmed by that unit circle from last section. Okay? What if I asked for this extension? What if I said find the general solution? Now I'm going back to section 4.1. So we found our four answers. They were pi over 3, 2 pi over 3, 5 pi over 3, and 4 pi over 3. Now, remember, general solution means we're going around the circle multiple times. Each circle has a radian measure of 2 pi. So all we're really doing is just adding 2 pi n, where of course n belongs to the set of integers, doing that to every single initial answer we got between 0 and 2 pi to satisfy this question's desire for the general solution of all things. That's it. Okay, exercise 3 is up to you. Remember how I did this with you earlier today too? This is like x squared equals to x. Yeah, you figure it out, okay? I'll be quiet. Go ahead and enjoy. Where is cosine theta equal to 0? Well, if you inverse it, you, I believe, get pi over 2. Once again, that's right on the y-axis. If you go back to that unit circle, that's not the only answer. That's also another one, 3 pi over 2. Okay? So once again, we're talking about general solutions. So from these two, pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n, where n is an integer. Some of you will be thinking, Mr. Lee, can I just combine them to get into 1? Yeah, you can. That's really just pi over 2 plus pi n, because it repeats every pi. N equals the integers. That's okay as well. But if you can't get that, the answer in black is very, very good. Going back to the other one, cosine theta equals to 1. Inverse cos must be, I think, 0. Okay. What angle has x value being equal to 1, 0, and also 2 pi, and so on and so on and so forth. So the general solution would just be, what, 0 plus 2 pi n, and is an integer. Most people don't write down 0 plus 2 pi n, so we'll just erase the 0 and the plus. We'll just leave it as 2 pi n. So here's your general solutions. Alright, let's do one last one, and then we'll be done chapter 4. Okay? This stuff's not hard, it takes a little bit long. I'd really strongly suggest you do as much homework as you can from this, especially because we're going to see this trig equation stuff again in chapter 5. Okay? Spend the time now, you'll be thankful for it afterwards. Okay, last one, example number 4. Okay? Save the toughest for last. Solve 4 cos theta equals 6 secant theta minus 5 in this domain. Once again, please, please, please try and only have one trig function. I can't do it with 2. That's just too much work. And there usually is a relationship between the two. What is the relationship between cosine and secant? Secant theta, and this is why you learned earlier this term, or not this term, this chapter actually, is equal to 1 over cos theta. Knowing that, make the substitution, and here's our new equation. 4 cos theta, 6 times 1, which is 6, so over cos theta minus 5. Okay. Now you have to remember that stuff from grade 11 where you did the rational expressions. Try to find, or I guess I'll say, try to get rid of that denominator of cosine theta. You can do this a few ways. You can multiply both the left side and the right side by cosine theta. And if you do that, you get 4 cosine theta times cosine theta. Cosine theta times cosine theta is just cosine, what we call squared theta. 6 over cos theta times cos theta is just 6. And then 5 times cos theta is just minus 5 cos theta. Why is this nicer? Because now I can move everything to one side, and it looks like one of those questions we just did earlier in this unit. Sorry, not even in this unit, in this section. For cosine squared theta plus 5 cosine theta minus 6 equals to 0. And now, factor. Once again, whichever way you want, I won't do it for you. Go ahead, take some time right now, please, and do this. Alright, so I will do this one first. Cosine theta equals to, sorry, I guess I'll go plus 2 equals to 0. Isolate the cosine theta. And now what happens when I do inverse cos of -2? You can try the calculator if you wish. Cos inverse -2. Error. Error. No such answer. Right, because there is no way of getting -2 as your x value, especially when we're talking about the unit circle. So no solutions from this part. But of course, we still have this other part. So we better solve that. So 4 cosine theta minus 3 equals to 0. 4 cosine theta equals to 3. Computer seems to be lagging. Cosine theta equals to 3 over 4. And go ahead and solve. This is not a special angle. Hello, Mr. Calculator, we need your help. Cos inverse. This one we can do because 3 over 4 is less than 1. 2.42. Theta equals to 2.42. Oops. Did I make a mistake? Yes, I did. Cosine inverse of not negative 3 over 4, but positive 3 over 4. Oopsies. 0.72. Ha 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 ha. Scratch that out. Whee! Disappear. Disappear. Ah, there we go. 0.72 was a better answer. And then, once again, is that the final answer? Nope, because we've got all students taking some sort of calculus. We've got an answer here in quadrant 1, which makes sense because cosine is positive. But where's my other answer? How about in quadrant 4? Because that's where cosine is also positive. Take 2 pi minus the reference angle of 0.72. 6.28 minus 0.72. What is that? 5.56. Let me just double check. 2 pi minus 0.72. Oh yeah. Oh yeah. Yes, we're done. That's it for chapter 4, everybody. It's time to do some practice.